Yesterday you tossed coins, today you tossed cups. We're thinking about what gives Calvin the greatest chance of getting the cereal that he wants to eat. And so today in homework you're going to continue to explore that. If you didn't quite get the big idea from today in class, hopefully you'll figure it out from your homework. Make sure you've had a chance to complete page 5 yourself and then correct it with this option. Calvin tosses a paper cup once each day for a year to determine his breakfast cereal. Use your results from problem 1.2 to answer the following. How many times do you expect the cup to land on its side? If we visualize the cup for a minute and think about the sides, you might have found some different probabilities in terms of your data in class today. But if I think about the sides of the cup and I compare it, for example, to the sides of a cube, if I look at this, I think about how a cube would have 6 different sides, right? The top, the bottom, and then the 4 sides around it. So it has 6 total sides. And if I think about what's happening on the cup, when I talk about how the sides of the cup kind of match up to the sides of the cube, I can see that it kind of matches up with like 4 of the sides on the actual cube. Again, I know this is a little bit tricky to visualize. It's probably easier to think about how that compares to the ends, right? The top and the bottom. You can see those a little bit more clearly when I shade them on the cube, right? That goes with 2 out of the 6 sides. So if I think about it, I'm expecting to get a cup that lands on its side 4/6, which is equivalent to 2/3, which is equivalent to 67% of the time. I'm expecting to get an end 2/6, which is equivalent to 1/3, which is equivalent to 33% of the time. So it's much more likely, from what I'm expecting, for me to get a side rather than an end. So let's think about how many times will I get a side for a year? Well, 4 out of every 6 times I think I'm going to get a side. So I might set up a proportion. 4 out of 6 equals what out of 365? If you did this way, you might have found a scale factor. 6 times 60.8 approximately would give me 365. So 4 times that same value is going to give me around 243. I'm just going to round it to the nearest day. So I would expect 243 times the cup will land on its side. What about its end? How many times do you expect the cup to land on one of its ends? Well, you can solve this lots of different ways. Maybe you set up a proportion, just like we were saying, 2 out of 6 equals what out of 365? Or maybe you think about how if there's 365 days in a year, if 243 of them, it must land on its side, or it might land on its side, then how many times would it land on one of its ends? If I subtract what I expect to get for the sides, I'm left with 122, which is a pretty reasonable estimate at this point. How many times do you expect Calvin to eat Cocoa Blast in a month? Well, you kind of have to make a choice here about how many days are in a month. So I would think he's probably going to choose sides, right, which have a chance of 4 and 6. And then I'm going to think that he probably is going to use a month that has about 30 days in it, right? I know months can fluctuate between 28 and 31. I'm going to lean towards 30. In this case, this is a pretty simple scale factor to find. Since 6 times 5 is 30, 4 times 5 would give me 20. So 20 is a reasonable estimate for about how many times I'd expect him to eat Cocoa Blast in a month. Again, I'm assuming that he's choosing sides since that's more likely to occur. How many times do you expect Calvin to eat Cocoa Blast in a year? Well, if I take my prior estimate, which is 20 times in a month, and I multiply by the number of months in a year, I get 240. So I'm thinking that's a reasonable estimate. And if I notice up here, I would expect it to land on its side around 243 times. So that kind of matches up here. I'm expecting him to get his preferred outcome around 2/3, 4/6, 67% of the time. Dawn tosses a pawn from her chess set 5 times. If you're not familiar with a pawn, it's just a small chess piece, kind of looks like this. And it lands on its base 4 times and its side once. Andre tosses the same pawn 100 times. It lands on its base 28 times and its side 72 times. Based on their data, if you toss the pawn one more time, is it more likely to land on its base or its side? Explain. Well, what I'm going to think about here is, I notice for Dawn that it looks like the base is more likely. But I also notice that in terms of trials, Dawn only did 5 trials, right? Dawn only tossed the pawn 5 times, versus Andre tossed this 100 times, 100 trials. And so one of the things we've been talking about is when we do more trials, it's more likely that we'll get closer to the expected values, right? It's more likely when we flip a coin multiple times, so we'll get closer and closer to finding that expected probability of 50% for heads and 50% for tails. However, if I only flipped a coin twice and I got heads both times, I might think that I have a 100% chance of getting heads, that I'll get heads every time. However, again, more trials gives us potentially more accurate data. So looking at this situation, when I'm thinking about is it more likely to land on its base or its side, I'm thinking about how my second student, Andre, did more trials. And so I'm more inclined to think that it's more likely to land on its side because this has had more trials. Now, you can make arguments for this in another way, but this is kind of where we're going at this point, is thinking about how if you've done more trials, you're more likely to know what's about to happen, or what's approximately the probabilities that you expect to happen. Use the graph to answer the following questions. Suppose 41,642 people moved. About how many of those people moved for family-related reasons? I'm hoping you're noticing that the graph here says percent. And so looking at this value here, I'm going to say maybe it's close to 25%. And so I want to find 25% of 41,642. One way to find this would be to turn the percentage into a decimal and multiply by 41,642. There's other ways to set this up as well, but my approximate answer should be 10,411 people. I'm not probably going to have a partial person. I'm going to round to the nearest whole number. For B, what fraction of the people represented in the graph moved for reasons other than work-related, housing-related, or family-related? I'm looking here at this other section, and I can see that this goes with about 5%, maybe it's about halfway. So I'm going to think about what is the fraction for 5%. Well, percent means out of 100, and then I can simplify a little further. So 5 out of 100 is equivalent to 1 out of 20, right? Since I can divide the top and the bottom by 5. Suppose 41,642 people moved. About how many moved for housing-related reasons? I'm looking here at housing, and it looks close to 50%. So I want to find 50% of 41,642. You might have noticed we found 25% earlier. So we could think to simply double that value and make it 20,822. Another option, though, would be to actually multiply 0.5 times 41,642. Either way, you should get approximately 20,821 or 22, depending on how you round. That's it for your homework today. We'll see you tomorrow for more fun with probability.